Alright, so in this video we're going to take a look at arrays in C++. And our objectives for this particular video is to look at what exactly is an array, so provide a definition of an array, and then the purpose of arrays, so how do we go about using arrays and when do we use them. And we'll also look at the syntax for arrays in C++. So let's go ahead and get started. Okay, so here we have a definition of an array. An array is a contiguous series of elements of the same type where each element can be accessed by a name and an index. So let's look at each one of the parts of this definition and try to get an idea visually of what's going on. So this first part, we have a contiguous series of elements. So what we think of, and when we say element here, is just a cell, a box. So I'm going to draw an array here, and I'm going to use a different color. So we have this array, and in this array, we have 5 elements. So we have 1, 2, 3, 4, and 5. So 1, 2, 3, 4, and 5. So this is our 5-element array. And we notice that we have this word contiguous here. And contiguous just simply means that these elements, these little cells that we have, are adjacent to one another. So behind the scenes, what's really going on is each one of these elements is occupying an adjacent location in memory. So whatever we have here would be adjacent to this memory location here, and the same case here, and so on down the line. So it's not like each element is spread over a vast range of memory where we have this element at memory location 1 and this one's at memory location 550. This would be at memory location 1 and this would be at memory location 2. So that's what's going on there with a contiguous series of elements. The next part we have is it has to be of the same type. So a fancy word for being same type is homogeneous. So sometimes if you're reading about arrays, you may hear about it being a homogeneous structure. That just simply means that whatever we place in these elements here have to be of the same type. So we could have maybe a character array, so all 5 elements would hold characters. We could have a string array where all 5 elements held strings. We could have a double array. So it really doesn't matter what it is. But what we cannot have is a mixture of data types. So we couldn't have a string in the first element, a double in the second element, an int in the third element. We cannot have that type of mixture. So that's what it means by same type. And the last part we had on the second line here is that it can be accessed by a name and an index. So I'm going to take this second part here where it has index. What happens is we have a position for each one of these elements here. So the way it starts with the indexing is that this would be index 0 or position 0. This would be position 1. This would be position or index 2. And then we'd have 3, and then we'd have 4. So here we have what's considered to be a 5-element array of some particular type. And these are the indexes. And you'll notice that with this particular array being of size 5, the very last element has an index of 4. So that's a unique or specific property dealing with arrays. It's the last element in our array will always have an index one less than the size or length of our array. And the length or size of the array is just simply how many elements we have. Now what happens is whenever we go about creating an array, we give it a name. So this particular array here may be array A. So the way we go about accessing a particular element is by specifying the name of the array, in this case A, and then an open square bracket, and then some index like 0, and then close square bracket. And that allows us to access whatever we have here. I haven't specified, what this array is in terms of the type. That's something we'll get to in a bit. But we would be able to access whatever that thing there. So if we had, say, a character, maybe this is a character array, and we had the character we'll say we have the character C here. So if we had the character C here, we could retrieve that character by using this syntax here, A, open square bracket, 0, close square bracket. But it also really depends on where this shows up. If it's on the right-hand side of an assignment statement, we would say that we were being able to access or retrieve that value. If this showed up on the left-hand side of an assignment statement, that would allow us to store a particular value there. Okay, so before we take a look at the syntax associated with arrays, let's talk about the purpose of an array. So we got this general idea of what an array is, but why do we use them? Where do we use them? So an array is used to keep track of related data where we know the number of elements required And the reason why I state that we need to know the number of elements required is because once we create an array, that's it. We cannot change the size of it. And that doesn't mean that we should go out and create 5 times or 10 times the amount that we think we may need. We should only really be using the array in cases where we know the number of things that we're going to have and it stays fixed. We don't have to change it. So let me give you a couple of examples. Say that we have an instance where we want to keep track of maybe a basketball player's points that they've scored for each game over a season. So in the NBA, they play 82 games. So if we wanted to keep track of a particular player in terms of the number of points that they've scored for each game over that particular season, or at least the regular season, is that we would need to create an 82 element integer array. And the reason why it would be an integer array is because we don't need to keep track of a fractional part. We don't have fractional points in basketball. Here's another example. So say we wanted to keep track of rainfall in a city for each day of the year. Then we could go about creating a float or double array in which we had 365 elements, assuming that we don't have a leap year. So these would be 2 instances where we'd make use of an array because all of this is related data. So for every single day of the year, we're wanting to record the rainfall, and that rainfall could have a fractional part, and that's why we have either maybe a float or a double, is because we need to be able to represent those fractional parts of rainfall. So these are really the big ideas in terms of the purpose for an array, is we want to use them to keep track of related data in which we actually know how many elements we'll need to have in advance. All right, so let's go over to Eclipse now and take a look at the actual syntax for creating and making use of an array and being able to access the elements. Okay, so I'm over here in Eclipse. I've already created a project called Arrays and created an Arrays CPP source file within that particular project. And we've done a pound include for IOStream. So we'll be making use of cout and cin. We're doing the using namespace standard, and we've already defined a main function. So inside of this main function is where we'll create an array. And the syntax for creating an array in C++ is just specifying the data type. So maybe I'll create a double array, but it could be an int, a string, depends on what your array is going to be holding. And then you supply a name for the array. And I'm going to say that this array is going to hold maybe the rainfall for a certain period. So we'll have rainfall, and then we'll do open square bracket. So within this open square bracket, close square bracket, in Eclipse it automatically appends the close square bracket for you. We'll specify the number of elements. So this is specifying the length or size of our array. So we'll say 5 just to keep things small. So we'll say that we'll be able to keep track of maybe 5 days of rainfall. So report the rainfall or store the rainfall for a 5-day period. And that is it. That is how we go about creating a 5-element array of type double in C++. And this syntax actually comes from C. It turns out that C++, or at least the most current standard that was sanctioned or ratified, whatever the formal term is, last year in 2011, they actually have an array container class that I'll probably show how to use in another video. Maybe the next video that I make will relate to that. But for right now, we're just looking at the classic C syntax for creating and making use of an array. So that's it. That's how we go about creating an array. If we're interested in assigning values to that array, or at least values that we would like to assign to it, turns out that this particular array would already have some values already there whenever we execute that particular line of code. But if we want to write our own values into those elements of the array, we would do something like this. We would say the name of the array, and then we'd specify a particular element within the open square bracket, close square bracket. So we'd do 0, and then we'd do assignment statement, and then specify some particular value. So maybe on the first day, we had maybe 2.3 inches. So we'll do rainfall, open square bracket 1, assignment statement, and then maybe 0.3, rainfall, open square bracket 2, assignment statement 0.0, rainfall, open square bracket 3. So all we're doing here is just simply assigning values for rainfall for each of these 5 days. I mean, this is 5 days of a particular, or 5 weekdays within a week. I'm just trying to keep the array short. So 4.1, and then we'd have rainfall, open square bracket 4, assignment statement, well, maybe we had a ½ inch or ½ a centimeter, however you want to think of it. So on line 15 here, we created a 5-element double array, named it rainfall, and on line 17, 18, 19, 20, and 21, what we're doing here is just assigning values into each element of our array. So this is the first element, and this would be the last element of our array. And notice how the very last element of the array has an index value that is 1 less than the size of the array. So that's an important fact to keep in mind. So if we wanted to, we could print out or output any particular value that's stored in the array. So we could do maybe cout, insertion operator, specify the name of the array, open square bracket, and then maybe we specify an index of 3. So that should print out 4.1 in this case. And then we'll do another insertion operator and do an indel, semicolon. So let's go ahead and save this, build it. So if we get any errors, looks like everything compiled fine. And now we'll run this bit of code and see what happens. So whenever we run this, you can see here on the console we have the value of 4.1, which is exactly what we'd expect to be outputted from that particular element in the array. Let me run this again. This time I'm going to make use of the debugger. So I'm going to go back up here and instead of hitting the run button, I'm going to hit the debug button just to show you that we have random values initially in our array. So I'm going to switch perspectives here and click on yes. So we're over here in the debugger now, and if I start stepping through this code, so I'm just using the step over button and interactively going through here. So we've created this 5-element double array, and you can see right now if we look at this particular array called rainfall that's of type double, that we have all these random values here. So for the very first element of our array, we have 4.77 blah 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 times 10 to the 253rd power. Wow. So we got some really weird values. You can see that these are this is a really large value and these are really small values here. At these for the second, third, and fourth element, and then we go back to a really large value. So these are just random junk values that happen to be at those particular memory locations whenever we created this particular array. So we can start stepping over, and you can see that we get a particular value. In this case, we assign the value of 2.3 into the first element. Now, the thing that you should notice here, if we look at this particular value, it doesn't say 2.3, it says 2.2999, repeating 9, I don't know, about 14 or 15 places of precision, and then it goes 8. So the thing about any of our real number approximations, like the double or the float, they're not stored exactly as we specify. It's just an approximation of that value, which it looks really weird whenever we see that, but that is the case. And maybe I'll have a video that kind of deals with that and why that's the case later on. But you can see that. So 0.3, you can see that's 0.299, 0, then we get 4.1, which is 4.0999, and then we get 0.5. So the 0.5 actually looks correct over here. And then if we do another step over, you can see 4.1 printed out. I just wanted to show you really quick how you could go about using the debugger to see the contents of the array before we actually populate it with any values that are meaningful to us in our program. So let me go ahead and I guess finish running this and go back to the C++ perspective over here for editing. And maybe we'll do this. Let's, instead of just printing out a single element of our array or the value of a single element of the array, let's traverse over our array. And the way we go about traversing or iterating or walking over each element of our array is by using a for loop. So we want to be able to repeat this operation of maybe printing something out, printing out each element or each value that's stored in each element of our array by using a for loop. So we can say for int I, assignment statement 0. So we just initialize I to 0. And then we'd say I less than, and this looks a little bit weird, but we're going to just specify 5 here, and then I++, and then we'll have the cout statement inside of the body of this particular for loop. And the only other thing we need to change, instead of having the open square bracket 3, we'll have an open square bracket something close square bracket. And what we want to be able to do is that each time we go through this for loop is to change this value, this index value that's being specified inside that open square bracket, closed square bracket. Now the cool thing is we can actually make use of this variable I, which is our loop counter variable. So it's being incremented each time we go through the loop. So if we specify I here, we should be able to run this and see every single value of our array being printed out on the console. So let me go ahead and save that, and then we'll build it. So we're compiling and linking it, and then we'll go ahead and run it. And you can see that we have 2.3, 0.3, 0, 4.1, and 0.5 being outputted. So that's pretty cool. Another thing that you may want to do is you could make use of this same type of for loop. So I'm going to just copy and paste this for loop that we just wrote so we can play around with it and see what happens. So what we could do is have this for loop where we ask the user for a particular value, and then we just insert that value or put that value, store that value into an element of our array. So say that we do a cout statement, so we say cout, and maybe we say enter a rainfall amount in whatever units that you like. So you could add that on to that string if you wanted to, but I'm going to just keep it generic and just say enter a rainfall amount, and then we'll do our insertion operator indel semicolon. And then in the next line, what we'll do, we'll just change up this just a bit here. We'll do, instead of a cout, we'll do a cin and use the extraction operator to store a particular rainfall into our array. So each time that we're going through this for loop here, we're able to ask the user to enter a rainfall amount, they enter that in, and then we just simply take whatever they inputted there and then just store that, and that's it. And if you wanted to, you could print that out again. So let me just copy this. And you notice how we're copying this code over again. And anytime we're copying and pasting code, you should think about, oh, we should be writing a function for that so that we're not replicating that code unnecessarily. So I don't want to get into writing a function just yet for this particular piece of code. And the reason why is it requires us actually passing an array to a function. I want to separate that out into another video. So what we're doing, just to recap real quick, is we created an array. We assigned values to each element of our 5-element double array called rainfall. Then we traversed over our array by using a for loop. And we started out where we had a loop counter I here starting at 0, going up to the value of 4. So 4 was the last time we were able to get into this loop continuation condition. You notice that I is being incremented each time through with this statement here. And here we're just outputting the value that's stored in each element, and the value of I is changing each time through. And then the next for loop, so it was the same basic for loop structure. We still had the same for loop header. We just changed up the body of this so that we're asking to enter in the rainfall amount. And then once we get that prompted to the user, we're going to read in that value by using cin, the extraction operator, and then we just specify a particular element. The way we specify an element of the array is just the name of the array, open square bracket, index, close square bracket. So that's just how we're going to read in a value into our element, and then we go back, print out the contents of this array. So let's go ahead and build this and see if we get any errors. Looks like everything built okay, and now we'll run it. And you see that we have these values being outputted here. 2.3, 0.30, 4.1, 0.5, exactly what we placed in the array initially. So that was outputted from this for loop here, and now it's doing this for loop where it's asking us to input something. So it's waiting on us to input a value. So we'll say maybe 2.7, 5.4, 1.2, 0.5, 0.7, and that's going to be it. So you can see that that is the last for loop that we had, the third for loop we had, just outputting the contents of our array. So one thing that I would encourage you to do is to play around with the debugger. So the debugger is really powerful. It may not be that useful whenever things are going well, but certainly being able to use the debugger and see the contents of the array, if you're getting some values being stored in an array that you're not expecting, maybe step through it and interactively go line by line and see what's going on.